All right, so the first problem there, we want to put it in slope-intercept form. You will remember that this is slope-intercept form. So basically, we need to just solve it for y. We need to isolate the y. And other than y, the only other thing there is the 6, so it's 6 times y. The way we're going to keep y, but get rid of the 6, is divide it by 6. Because 6 divided by 6 is 1y. And if we divide that side by 6, we also have to divide the other side by 6. When we do that, we get y, 1y, equals 3 divided by 6 is 0.5, minus 9 divided by 6 is 1.5. Now it's in slope-intercept form. 0.5 is your slope. Negative 1.5 is your y-intercept. Okay, the next one. Riley? 0.5. 3 divided by 6 is a half, or 0.5. Okay. The next one, right? 12x minus 3y equals 9 in slope-intercept form. Okay, and this one, again, we need to isolate this y. We have more to get rid of than we did in the last problem. We have to get rid of this 12x completely. We don't want anything left. So that means we want to subtract it away. So if we subtract both sides, 12x from both sides, or add negative 12x, then 12x minus 12x is 0. And now we're left with negative 3y. And on the other side, we have 9 minus 12x, or negative, nope, not negative 3. They're not like terms. All we can do is write an expression that represents 9 minus 12x, or negative 12x plus 9, either way. It's fine. And what do we do now to get rid of this negative 3?
Divide.
Divide by negative 3, because negative 3 divided by negative 3 is positive 1y. So we're going to divide both sides by negative 3, and now we have y equals negative 12 divided by negative 3 is positive 4. And 9 divided by negative 3 is negative 3. And you can either write plus negative 3 or minus 3 would be the simplest way to write that. So y is equal to 4x minus 3. Now in number 7, we want to know which of these equations describes the same relationship. In other words, we want to know if any of those equations are exactly the same. The easiest way to do that is to write them all the same way. And this one right here looks kind of simple, doesn't it? So it's x equals something. All right, so I think the easiest way would be to solve them all for x. So have them all say x equals something. What is the only reason why this doesn't say x equals something?
Because there's a 2 in the way.
Yeah, and that's 2 times x. So how do you get rid of the 2 but not get rid of the x?
Divided by 2.
Divide both sides by 2. And now we have 1x is equal to 2 divided by 2 is 1y. 4 divided by 2 is 2. So now just look closely. Is this one exactly the same as this one?
No, there's a negative.
Yep, one's a minus. So those two aren't the same. Okay, now let's look at this one. Other than, what's the only thing keeping this one from being just x equals something?
Negative 2.
The negative 2, and how do we get rid of that negative 2?
Divided by negative 2.
Divide both sides by negative 2. Negative 2 divided by negative 2 is 1x. What's 8 divided by negative 2?
Negative 4.
What is negative 2 divided by negative 2?
0.
No, when you divide a number by itself, you get
1.
1.
Negative.
So it's just positive 1. Because it's,
Yeah,
one thing you can do so you don't have to worry about the signs is change any minuses to adding a negative. So you have negative 2 divided by negative 2, which is positive 1y. Now, is that one the same as either of the other ones?
No.
No, it has negative 4 in it. All right, the last one. The last one, we have a lot of stuff that is not x. If you want to get rid of something completely, like this negative 2y, you just add the same, you add the opposite, or subtract it, or whatever. But if we add 2y to negative 2y, that eliminates that, that makes it 0. So we're going to add 2y over here also. And now, that's 0. So we have 4 minus 2x is equal to 2y. We want to also get rid of that 4. So we're going to subtract 4 from both sides. So now we have negative 2x is equal to 2y minus 4. And now we can just get rid of that last negative 2 in front of the x by dividing by negative 2. And we get x equals 2 divided by negative 2 is negative 1y. And negative 4 divided by negative 2 is positive 2. Is that one the same as any of the other ones?
Yeah.
No.
It isn't. None of these are the same. All right. And the last problem.
She said wait.
Who said wait?
That's good now.
You're good now? All right. In this equation, what we're wondering is this linear or nonlinear? If it's linear, it should fit this form, the slope-intercept form. So in other words, there should be something times x plus something. Now, if we look closely, one reason it's not in this form is, oops, I changed that, adding a negative. One reason it's not in that form is this is a negative y, and that's just y. So, and remember, negative y is the same as negative 1y. So what we could do to get rid of that negative 1 is just do what?
Subtract it by or add. You would subtract?
If you subtract, then you get rid of the y. We don't want that. We want the y to be there,
Yes. So divide by 1.
divided by negative 1, because then it makes it positive 1y. So we have to divide both sides. I'm going to rewrite this last part here. This is x divided by 5. There's a number you can multiply that's the same as dividing by 5. You guys know what it is? If you divide something into 5 parts, what fraction are you left with?
1/5.
1/5. Yeah, so 1/5 x is the same as x divided by 5. Okay, now I want that divided by negative 1. So negative 1 divided by negative 1 is positive 1y. 7 divided by negative 1 is negative 7. Negative 1/5 divided by negative 1. Remember, dividing by 1, it doesn't change it. It keeps it the same. Just changes the sign, right? Negative divided by a negative is
Positive.
positive. Now, if you look closely, this kind of looks like this. What number is being multiplied by x? 1/5. And is there something else being added on? Negative 7. Yeah, this is linear. The slope, the letter we use for that is m. It's 1/5. And the y-intercept, the letter we use for that is negative 7. All right, so practice those other 8 problems, and then I'll let you retake that quiz.